Now psi cos kx, P, the probability density psi mod square. Okay, let me write this one P, but understand this is not the probability but the probability density. Cos square kx and cos square, and for kk these are particle waves, electrons, quantum mechanical particles, P over h bar and x. But there is one principle that you know, that if you want to measure the momentum and position of a particle at the same time, then this will give you some error. And the error in this one, and the error means the uncertainty, and this one will be greater or equal to h bar over 2. So it means for my particles, quantum mechanical particles, or for my particle waves, I cannot write these things together because their calculations will be problematic. And let me give you an example. Let's say, classical example. Okay, I'm sorry for my drawing, but this is the best I can do. Let's say a car is going this way with certain velocity v. Can I determine its position and momentum at the same time? How I determine? Because I know from some source photons are coming in, and those photons are reflected from this car and they are reaching my eye. This is a detector. Now this photon imparts some energy to this car, but is this photon able to change the position of the car? No. So for classical physics, it doesn't matter. Now you are dealing with a quantum mechanical particle, and a photon comes in, and here is a detector, the eye. Does it matter for the electron when this photon will hit it? It matters. So it means the uncertainty principle here is not working, but the uncertainty principle here is working. If this electron was going this way and the photon comes that way, so the photon will give me the information that yes, the particle momentum was this much, but the photon will say the particle was stationary, but the particle wasn't stationary. That photon has made that particle stationary or reduced its speed. Clear? Now when this particle was stationary, my quantum mechanical particle was stationary, and the photon comes in and it says this was the position of the particle, but the particle was in motion while my quantum mechanical particle was at rest. So there is always uncertainty between the measurement at the same time. Now this uncertainty is also quantum mechanical. You say h bar 10 power minus 34, 0.000033 zeros and then 1. But it does matter for a quantum mechanical particle, not for this one. We will study the Heisenberg uncertainty principle in detail, but it is just to give you a clue that we cannot write this one only cos kx, because here the conflict of these two is coming in. And when we will study the commutation operators, then we will study this thing in more detail, that their measurement actually changes the system for each other, and that's the reason the uncertainty comes in action. Okay, so we can not do this thing, but we will have to add this term with it. And you know that if I want to plot this function like psi square, like sine equals cos kx plus I sine kx, then I can plot my sine. If on this side I am having r and on this side I, then the sine is actually this thing, and this component, which is the x component, is cos x. So consider this is x not r, cos kx, and this will be sine kx along the vertical component. This side is decomposed into components as you do the vector decomposition. Now, can I do like this, that psi square, and you square all this thing, like cos square kx plus I sine square kx plus 2 times cos kx and I sine kx. This is the simple square, but the complex numbers are not supposed to be squared like that. This is not like this, that cos kx plus I sine kx whole square. And then with the help of a plus b square, you expand this one. Now it's not true. Whenever a complex number comes in, then the squaring is different. And that squaring is sine mod square will be psi conjugate into sine, because its square will come to the real world, while psi is in a complex world. So sine mod square should not have any involvement of iota, and this will be equal to conjugate of this one multiplied with the wave function, and you know that it will have no iota involved then. So this is the wave function. It is having complex component, but when it comes to the real world, then it will have no iota involvement. And that whenever you will do the measurement, you will have this situation that the measurement will be real in the real world. So we will have to write it like this, not like this, because this is not the way to do the complex numbers. Now you know about another thing, the concept of mean Bohr and the concept of Deriving. What Niels Bohr said? Niels Bohr said that an electron is actually revolving in a circular orbit, and when as long as it is revolving inside this orbit, it is not emitting electromagnetic radiations. Although the motion is accelerated motion, electron is a charged particle. The basic electromagnetic theory says that when a charged particle is accelerated or decelerated, it will emit electromagnetic radiations. But here, this orbit, the charged particle is accelerating here, but it is not emitting radiations. And he solved the problem with the help of discrete orbits. That a particle with a certain momentum our angular momentum will go in this orbit. It will only absorb radiations or emit radiation when it will change this orbit. But when de Broglie's come in and the particle waves come in, he said that actually the particle is not going, or the electron is not going in a circle, but it is actually behaving like a standing wave. And then it will be, you can say, the wave which will decide, sorry for my drawing, but this one a bit prolonged and this one a bit collapsed. So here like this. Means the wavelength will be, wavelength, so it will be equal to the circumference. It's the same thing, but this motion is actually responsible for not radiating electromagnetic radiations. Clear? Means traveling wave will do this thing, but stationary wave or standing wave will not emit radiations. So let's say we suppose that the circumference of this orbit is actually, let's say, is L, capital L. Now I can write that L is equal to 2 pi r, and r is the radius of this, then it will be equal to 2 pi r. Now if I write that psi is equal to EIKX, then it's a circle. So if I go one, this one is psi x. If I go one circumference more, I will have the same function, like kx plus l. These two functions means psi x plus l will be equal to this, but there will be no difference between this wave and this wave. They will be the same because it is the same wave, but it is repeating itself after the circumference. So I can say that e to the power ikx will be equal e to the power ikx plus l. These are the same waves. Just a repetition after 2 pi. Just a repetition after L, which is the circumference. Then I can write this EIKX. This I can write EIKX into EIKL. Now this one is cancelling. So this gives me that EIKL is equal to 1. Clear? Of course, when this one is cancelled with this one, so it's 1 here. So EIK is equal to 1. You understand this? Means this is a standing wave, and this wave repeats itself after covering L distance, or we say it repeats itself after covering this much angle. So it is the same wave, this one and this one, because it is the same wave which has just repeated itself. So this is equal to this one. Now if I write EIKX is equal to this one and I split this one, then this and this are cancelling, giving you 1. And EIKL is equal to 1. So I can write that this EIKL from here is equal to cos kx and sin kx. So I can write that this one is cos kl plus I sin kl is equal to 1. When this one will be equal to 1? Because this is equal to 1. I don't know the value of this one, right? I don't know the value of this one. But if this value, because this is the domain of cos and this is the domain of sine, I know that the domain of sine starts from 0 to 2 pi. After this it repeats itself. So when this one is equal to 0, then this one is equal to 0 as well. So this one sine 0 is 0 and cos kl is equal to 1. So it means the only possibility is that when k is equal to 0, then this is equal to 1. Is there any other possibility? Is there any other possibility? If k is equal to 2 pi, then sine 2 pi is equal to 0, but this one is equal to 1. So it means that when kl is equal to 2 pi, this is also true. When k is equal to 4 pi, right? Then again this is true. So it means that when kl is equal to n times pi, or n times 2 pi, if you like, then
3 pi पर फिर वो
okay, so n times 2 pi, and n is equal to 0, 1, 2, 3, 4, 5, all they are true. So n is equal to 0, 1, 2, 3, and so on. So I can write that kl is equal to n times 2 pi. Now what is n equal to from here? K and n is equal to 2 pi r. This is equal to n times 2 pi. 2 pi is cancelling with 2 pi. And I get that k is equal to n over r. Okay? N over r. Now what is k? You remember from here. K is p over h bar. So this is p over h bar equals n over r. You know the value of n. This can be 0, can be 1, 2, 3, and so on. So from here I can write that PR is equal to n times h bar. PR is equal to n times h bar. Or from here I can write that P is equal to n times h bar over r. Now what is this? This is momentum. And momentum comes out to be the integral multiple of h bar. What is this one? This is angular momentum. Because L is equal to r cross p. Angular momentum is r times p. So PR is angular momentum. So this gives you that angular momentum is actually equal to n times h bar. Both the linear momentum and the angular momentums are quantized. But as the particle is moving in a circle or moving in a wave, so it is angular motion. So we talk of angular momentum. And angular momentum is actually integral multiple. It is discrete. Means it is not possible that in this L circumference any type of wave can accommodate. No. Either one wave will accommodate, either two waves will accommodate, either three waves will accommodate, 4 and so on. And this was the reason of quantization. That quantization came in there by taking all this thing like this, EIKX. So we will have to take our wave function is IKX, not KX, right? So this will be our proper wave function for our quantum mechanical particle. Because if we only write kx, then there is a problem of its calculation. So we will have to adopt this one. Clear?